Hi everybody, Dr. A here, and in this video we are going to be discussing what are known as matrix equations. So what is that? Well, a matrix equation is pretty much exactly what it sounds like. It's an actual equation that has matrices and vectors inside of it, okay? So this is not quite the same thing as maybe what you've watched in some other videos or what you've learned before with performing row operations and expressing a matrix in reduced row echelon form or transforming a system of equations into a matrix and then achieving row echelon form. It's not quite the same thing as that. So in this particular topic, what we're discussing is how we can use matrix multiplication to write a system of equations as what's called a matrix equation. So again, it's a little different than what you have seen before with expressing an equation system as an entire single matrix and then performing row operations. It's not the same as that. So let's talk about what we're dealing with here. So a matrix equation has the form matrix A multiplied by a column vector X, and that being equal to another column vector B. Okay, so this is how we express this. We have a matrix A times a column vector X, and so I'll put this little vector notation above this term X, equals another column vector B. So let's talk about what each of these three terms are, okay? Matrix A is sometimes called a coefficient matrix from the equation system. So if we have a system of equations, matrix A is going to have all the entries of the constants or the coefficients of the variables, okay? So that's what matrix A is. What about column vector X? So this is called a column vector representing the variables in the equation system. Okay, so again, if you're dealing with a system of equations, then this column vector, or sometimes called a column matrix X, represents the variables. Its entries are all the variables that are from that system of equations you're interested in. And then what about this last guy here, column vector B? Okay, so column vector B, or maybe you may call it a column matrix, is a column vector whose entries are the constants on the right side of the equal sign in the equation system. Okay, so let's look at a generalization of this. Let's say that we have this equation system. Let's call it, let's say we have A11x plus A12y equals B1. And then our second equation, let's say we have A21x plus A22y equals B2. So this right here is just a very generic system of two equations with two variables. So let's make a note here. X and y are variables. Okay, those are maybe our independent variable and our dependent variables. And then if you notice, these little a values represent the constants or the coefficients multiplied by each one of the two variables in each equation. So this A11 represents a number times X, A12 represents a number times Y, and then these B values, B1 represents the constant on the right side of the first equation, and then B2 represents the constant on the right side of the second equation. So what we can do is we can use this idea of matrix multiplication and represent this system like the following. We can represent, see if I can spell that right. We can represent this equation system as the following matrix equation. So watch what I'm going to do here. I can make a 2 by 2 coefficient matrix of the coefficients of the variables A11, A12, A21, and A22 times a column vector representing the variables, and so it has the variable designations x and y, equals another column vector b1 and b2. Now, you may be wondering, how did I get to this? Well, I use the idea of matrix multiplication. Watch this. It's like using matrix multiplication but going backwards. This first row of the left matrix, which is my coefficient matrix, if I multiply it by the first column of this right matrix here, I'll have A11 times x plus A12 times y equals B1. And sure enough, that's our first equation. And then followed by A21 times x plus A22 times y equals B2. And sure enough, that's our second equation. So what we've done here is we've taken a system of two equations with two variables, and we've kind of repackaged it into what's called a matrix equation. So this first 2 by 2 matrix, this is our coefficient matrix. This 2 by 1 that we're multiplying by the coefficient matrix is our column vector of variables. And this third matrix, this 2 by 1, is our column vector of constants. Okay, so that's it in general. Let's do an example with numbers, with real numbers. Maybe that'll help resonate with people. So let's look at an example here, and let's say given, and let's say we just are being told to represent the equation system as a matrix equation. Okay, so I'm just going to make one up right now. Let's say we have x plus 3y minus z equals 1. Let's say we have 2y plus z equals 3, and then let's say I have negative 2x minus 4z equals negative 2. Okay, I just made this up. Okay, but what is this? This is a system of 3 equations, and you have 3 variables, x, y, and z. Now, some of the coefficients are 0. That's okay, but I've written this in an organized form. So then I'm going to write solution. And so the first thing I'm going to do is I'm going to write my coefficient matrix. So my coefficient matrix will contain the constants multiplied by each of the variables. Okay, and so my coefficient matrix for this will have the form A, and then the matrix equation totally will be A times x equals B. Okay, so A, coefficient matrix A, will be 1, 3, negative 1. And maybe pause the video and see if you can, finish it off. Pause the video because I'm going to tell you the answer now if you want to do it on your own. 0, 2, 1, negative 2, 0, negative 4. So again, this 3 by 3 matrix A, all of its entries are the coefficients of my 3 variables, okay? And so as a matrix equation, I can write the following. I can write 1, 3, -1, 0, 2, 1, -2, 0, -4 times my column vector of variables. Remember, I have three variables now, x, y, and z, equals my column matrix of the constants on the right side of the equation, 1, 3, -2. And according to the directions, that's it. This is my answer. This is how I write that system of equations as a matrix equation, okay? So again, you can always kind of work backwards and think about it. If you think about this is doing matrix multiplication, but like the opposite way, this is like undoing matrix multiplication. You've got row 1 times column 1 equals 1. That's our first equation. We've got row 2 times column 1 equals this number 3. That's our second equation here. And then we have row 3 of the left matrix times the one and only column of the right matrix equals -2. That's our third equation. So again, this technique is really, it's really just used to express a system of equations in a different form, and that form is called a matrix equation. Now, in a full-blown linear algebra course or maybe a graduate level engineering course, you would do more with this. There's some advantages of writing equation systems in this form. You can perform some other mathematical manipulations more conveniently when you're dealing with a system of equations written as a matrix equation. But for the purposes of this video, I just want to show you how to do it, and that you're basically using the idea of matrix multiplication to express this equation system in matrix equation form. So that's it. That's going to conclude this video. Thanks for watching.